In this module, we'll move from PKI runbooks to how application teams actually consume certificates. You'll see how to design self-service workflows that feel simple for developers while still enforcing strong policies, approvals, and guardrails behind the scenes. Most enterprises still run PKI as a cryptographic silo. Everything is ticket-driven, relies on a few experts, and reacts to incidents instead of preventing them. That model doesn't scale when every app, device, and cloud service needs certificates. Our goal is a platform mindset. Policies define what's allowed, automation enforces guardrails, and teams interact through simple, task-oriented workflows. PKI becomes an internal service, predictable, reusable, and integrated with IAM, so application and identity teams can move quickly without sacrificing control. In a mature PKI program, ownership is split between two groups. PKI and security operations define and guard the trust model. They run the route and issuing CAs, design templates, enforce enterprise policy, and handle CA-level incidents and audits. Application teams then consume that trust. They generate CSRs and keys, keep those keys secure, deploy certificates into their stacks, drive renewals, and respond to app-level outages. Making these boundaries explicit avoids finger-pointing and is essential for scaling PKI safely across many applications. A healthy PKI lifecycle also depends on clear ownership. The application owner drives the flow. They request certificates, generate keys and CSRs, deploy them, handle renewals, and eventually decommission them. PKI engineering concentrates on the trust layer. They approve requests, issue certificates, and support secure deployment and renewal. But they're not babysitting every app. Security and IAM act as governors. They define policies, review high-risk approvals, and must be informed when identities or applications are decommissioned so associated certificates are cleaned up. When you design CLM workflows, think in two lanes, speed and risk. Self-service workflows are for low to medium risk. Internal TLS, internal APIs, lab, and test systems. You rely on predefined templates, strong defaults, and full automation so developers or pipelines can get certificates instantly without opening tickets. Guided workflows are for high-impact cases. Internet-facing apps, sensitive domains, code signing, or new MTLS patterns. Here you trade speed for assurance, adding change tickets, human approvals, and SLA-based issuance. When you design a certificate portal, think like an application owner, not a PKI engineer. Lead with goals such as secure a web server, authenticate an API, or onboard a device, instead of low-level tasks like generate a CSR. Users choose the outcome, and you translate that into the right template, key size, and validity. Use sensible defaults that already meet your enterprise standards, so most requests become one-click operations. Then embed next-step guidance directly beside each action, so users don't need external docs to complete enrollment, deployment, and verification securely. This model lets you hide PKI complexity from application teams without losing control. Deep down, you've got roots, cryptographic constraints, privileged templates, and messy SAN rules. Those remain owned by the PKI team. Above a strict RBAC barrier, app owners only see contextual options like internal API certificate or external web TLS. Each friendly option maps to hardened templates and rules underneath. Your design goal is to expose intent-based choices, while locking down everything that could accidentally weaken the cryptographic engine. Picture certificate requests flowing through a funnel before they ever reach your issuing CA. First, validate syntax and scope. Is the hostname well-formed in an approved domain and not an overly broad wildcard? Anything suspicious is rejected immediately. Next, enforce policy. Only approved key sizes, algorithms, and templates are allowed through. Then pre-populate metadata like environment, business unit, or owner. The result is a clean, standardized CSR that's far less likely to create outages or audit findings later. To run PKI at scale, every certificate needs to be tied to a real service, not just a hostname. Begin with a strict naming standard. Encode app name, environment, region, and purpose, so anyone can infer what the certificate is for. Then attach ownership data. Which team owns it, which business unit, and who gets paged when it breaks. Finally, include operational tags that link to CMDB records, criticality tiers, and renewal policies. With this metadata, automation can reliably renew, monitor, and escalate issues for the right service. Now let's look at how CLM-driven CI/CD changes certificate handling. Your pipeline code kicks things off. Terraform, Ansible, or a CI runner requests a certificate as part of deployment. That request hits a CLM-aware API gateway, not a human-driven portal. From there, the CLM engine acts as invisible guardrails. It enforces RBAC, policy, approvals, and full logging automatically. The certificate is issued into a secure store like Azure Key Vault or HashiCorp Vault. Then the app retrieves a short-lived cert at runtime and binds it automatically. No manual copying, no long-lived secrets. Just-in-time enablement is how you make PKI usable for busy app and ops teams. Instead of long training sessions, you give them exactly what they need, right when they need it. That means clear runbooks for common tasks, copy-paste config examples for key platforms, and small verification steps they can run themselves. Combined with in-portal help, this turns PKI from a black box into a predictable service. To keep PKI adoption healthy, you need an enablement flywheel, not a one-time rollout. Start with targeted training so each role understands the how and the why of your PKI workflows. Enable frictionless execution. Portals, APIs, and CLM tooling should make the secure path the easiest path for app and ops teams. Then close the loop with metrics and feedback. Track failed enrollments, renewal pain, and support tickets. Finally, continuously refine templates, UI, and documentation based on that data, and repeat. To make PKI self-service actually work at scale, think in terms of 3 pillars resting on solid governance. First, people. You need clear ownership, RACI, and training, so app teams know exactly how to use certificates safely. Second, process. Design opinionated, low-friction workflows and SOPs that make the secure path the easy path and reduce chances of mistakes. Third, technology. Expose only the right templates, integrate with CI/CD, and automate secure key delivery. Underneath it all are your governance foundations: CP, CPS, risk assessments, and well-defined enterprise trust anchors.